So how and when can we observe this colossal celestial visitor? If you've never seen a comet in your life, this could be your chance, even if it's a subtle one. Comet K2, officially designated C2017 K2, Pan-STARRS, is not just rare for its size and origin, but also for how far it's traveled and remained active. Now that it has entered the inner solar system, visibility becomes a critical question. Let's talk about the most important detail: timing. The best period to catch a glimpse of Comet K2 was around July 14, 2022, when it passed closest to Earth. However, it remains visible for several months after that, specifically from May through September 2022, particularly in the Northern Hemisphere. You'll want to observe it during a window between 1 hour after sunset and about 3 a.m., when the skies are darkest and the comet is above the horizon. Next, the location in the sky. The best place to start looking is the constellation Ophiuchus. Also known as the Serpent Bearer, Ophiuchus lies between the constellations of Scorpius and Hercules, in a region of the sky that appears highest during summer nights in the Northern Hemisphere. Star map apps like Stellarium, Sky Safari, or Starwalk can be very helpful. Just input Comet K2 and they'll point you in the right direction. But can we see K2 with the naked eye? Unfortunately, no, or at least not under typical conditions. Astronomers estimated that at its brightest, K2 would reach a magnitude of around 7 to 8. For reference, the human eye can usually see objects up to magnitude 6 in perfect dark skies, and only from very remote locations with little to no light pollution. So, to observe Comet K2, you'll need at least a small telescope. A 4.5-inch reflector telescope is sufficient if you live in a rural or dark area. In urban or suburban environments where light pollution is stronger, a 6-inch or larger telescope will be much more effective. For amateur astronomers and hobbyists, this is a good opportunity to bring out your equipment, especially if you're familiar with tracking faint objects. Currently, as of the last reported magnitude, around 9.0, K2 is just faintly visible using a small telescope in dark rural skies. Its visibility may improve slightly, but it will never become as spectacular or as bright as famous comets like Hale-Bopp or Neowise. What makes K2 exceptional is not its brightness, but rather its story. How something from the farthest reaches of the solar system can still come to life and glow in the night sky. As the comet continues its approach toward the sun, it may brighten slightly or become more defined in shape. But keep in mind, comets are unpredictable. Solar heat can either activate them more intensely or break them apart. That's why astronomers and skywatchers alike remain cautiously optimistic when it comes to K2's behavior. Here at Infinity Beyond, we recommend preparing your telescope, finding a dark sky location, and setting aside some quiet time under the stars. Even if K2 doesn't impress with brightness, it rewards those who observe patiently, showing us a piece of the solar system's ancient past, still active, still glowing. In the next part, we'll look at the physical composition and mystery behind K2's behavior. Why is this comet so active from such a distance? And could it teach us something new about the chemistry of early solar system objects? Stick around with Infinity Beyond as we unravel the secrets of this icy wanderer.